VLSos here. This is a video lesson using U substitution for integration. I'm going to work an example. What if we wanted to find the antiderivative or the integral of 3/2 x to the 4th minus 3x all to the 5th times 2x to the 3rd minus 1 with respects to x. Well, of all the various integration techniques that we have at our disposal, U substitution is very often one that can work and is relatively easy to use. So it's worth a try. And in trying, what we want to do is we want to be clever as to what our assigned expression will be, what we're going to choose U to be. And it's often the case that U is going to be equal to the piece of the integrand that has or is involved with the higher exponential value. Reason for this is because after you choose U, you're always going to take the derivative of it, which will reduce the exponential value, often, hopefully, into another part of the integrand. So I see there's an exponential value of 5 here. I'm going to choose my U to be what is being raised to the 5th power. And that is 3/2 x to the 4th minus 3x. And immediately take the derivative of my choice with respects to the variable that is composing it. And the derivative is, if I bring down this 4 and multiply, then it's going to be 3 times 4 is 12. 12 divided by 2 will be 6. X to the 3rd minus the derivative of 3x is 3. Now, what I got after taking the derivative doesn't look much like the other piece of the integrand that I need it to substitute as well. But hopefully we can see that a 3 can be factored out of this expression. And I can give an alternative for what du over dx is equal to. As a factored form, 3 times 2x cubed minus 1. And when I factored out a 3, it's lucky that I had a chance to see that that could happen, then one of the factors does match what my original integrand is. For U substitution to work, everything in the original integrand or integral needs to be replaced with some expression of U. All the x, wherever they are, have to be replaced with versions of U or expressions for U. We can't have a combination of the original variable in U and expect to proceed. So something like this needs to work out. It didn't work out perfectly. If I multiply both sides by dx to get du by itself, then I'll get the 3 using this expression times 2x to the 3rd minus 1 dx. And here's what I mean by it not working out exactly. I'm going to attempt to rebuild the integral. This piece that is being raised to the 5th power was replaced with u, and it's still being raised to the 5th power. But when I replace or want to replace all of this, then what I'm replacing it with, I want to be du, but there's this extra 3 factor involved. So I cannot directly replace this with du because this doesn't contain that 3 factor. But I can modify this. I can get rid of the 3 factor on the right by dividing both sides by 3. When I do, the du will be divided by 3, and on the right, I'll get the 2x cubed minus 1 dx. Now this matches what I have yet to replace when we rebuild the integral. But what I'm replacing all of this with will be the du over 3 that it's equal to. So continuing on, I'm going to replace what's left with the du over 3. And to show what happened, this was replaced with the du, and all of this was replaced with, nope, this wasn't replaced with the du, it's just u, and this was replaced with du over 3. So I reconstructed the integral, but it looks a little bit odd. This division by 3 with this part of the symbol, not a problem. Think of the division by 3 as a factor of 1/3. And the 1/3 factor could be in the integrand, or because it's a constant, we could put it out front. And this integral is equivalent to u to the 5th du, where the division by 3, or I'm going to think of it as multiplication by 1/3, is out front. Now the integral looks like an integral that is written in a familiar way, and finding the antiderivative of u to the 5th is quite simple. So I'm going to take my last line of work, find the antiderivative of u to the 5th, which is u to the 6th divided by the new exponent, and this antiderivative is still being multiplied by 1/3, and we can't forget c. But to express my final answer, I need to replace what u is equal to. So it's 1/3. This 1 over 6 I'll list as a factor of 1/6. And u to the 6th is 3/2. X to the 4th minus 3x, all to the 6th, plus c. Now I could do some simplification. The 1/3 and the 1/6 could multiply it to be 1/18, but I'm going to stop there.